Step 2. Creating a geometrical set. After preparing the specification tree and renaming the initial geometrical set as input or a meaningful label, the next step is to create a new geometrical set for handling the top, middle, and bottom surfaces collectively. 1. Select the main product structure in the specification tree. 2. Navigate to the File menu at the top of the interface. 3. Choose Insert, and then click on Geometrical Set. 4. Rename the newly created set as Basic Surfaces. This set will be used to organize all operations and features related to the remastering of the top, middle, and bottom surfaces. It provides clarity and structure for managing these key areas efficiently. Step 3. Creating a point. With the Basic Surfaces geometrical set ready, the next step is to create a point on the top surface to serve as a reference for subsequent operations. 1. Select the Point tool from the toolbar. 2. In the Point Definition dialog box, use coordinates if the global planes align with the default origin, ensuring the coordinates match the default global plane origin. 3. Once the point parameters are set, click OK. The point is now added to the Basic Surfaces geometrical set in the specification tree. Step 4. Extracting the top surface. With the reference point created, the next step is to extract the top surface of the geometry. This allows us to isolate the surface and work on it independently while keeping the input geometry intact. 1. Ensure the Basic Surfaces geometrical set is active in the specification tree by selecting it. 2. Locate the Extract tool in the toolbar. 3. Click on the Extract tool and select the flat, horizontal top surface of the part. 4. In the Extract tool dialog box, set the propagation type to No Propagation to extract only the selected surface. Ensure the extraction captures only the intended top surface and no additional features. 5. Click OK to complete the extraction. The extracted top surface is now added under the Basic Surfaces geometrical set in the specification tree. Step 5. Untrimming the top surface. After extracting the top surface, the next step is to untrim it. Untrimming removes any trimming constraints and restores the surface to its natural boundaries, ensuring a clean and complete surface for further operations. Untrim the top surface. 1. Click on the Untrim tool in the toolbar. 2. In the workspace, select the extracted top surface. 3. In the Untrim tool dialog box, verify that the untrimmed surface extends to its original, full boundaries. 4. Review the preview to confirm the surface is restored accurately. 5. Click OK to finalize the untrimming operation. The untrimmed top surface now replaces the extracted version in the Basic Surfaces geometrical set, ready for further operations such as intersection curve generation or sketching. Step 6. Creating intersection curves. With the top surface untrimmed, the next step is to create intersection curves. These curves are essential reference elements that guide the reconstruction process. We'll generate these by intersecting the untrimmed top surface with the global planes. 1. Locate and select the Intersection tool from the toolbar. 2. In the workspace, select the untrimmed top surface as the first element. 3. For the second element, choose the XY plane from the specification tree or the workspace. 4. Click Apply to generate a horizontal intersection curve. Now repeat the steps for the vertical curve. 1. Locate and select the Intersection tool from the toolbar again. 2. Select the untrimmed top surface as the first element. 3. This time, choose the YZ plane from the specification tree or the workspace as the second element. 4. Click Apply to generate a vertical intersection curve. Both the horizontal and vertical intersection curves are now visible in the workspace and are added to the Basic Surfaces geometrical set in the specification tree. Step 7. Creating sketches. With the intersection curves generated, the next step is to create sketches based on these curves. These sketches will serve as guides for reconstructing the top surface. Create the horizontal sketch. 1. Select the Sketch tool from the toolbar. 2. Select the XY plane from the specification tree as the sketch plane. 3. Use the Project 3D Elements option to project the horizontal intersection curve onto the sketch plane. 4. Right-click the projected curve and select Isolate to remove its dependency on the original geometry. 5. Apply dimensional and positional constraints to the curve, ensuring the sketch is fully defined. Now, repeat the steps for the vertical sketch. 1. Select the sketch tool again. 2. Select the YZ plane from the specification tree as the sketch plane. 3. Use the Project 3D Elements option to project the vertical intersection curve onto the sketch plane. 4. Right-click the projected curve and select Isolate to remove its dependency on the original geometry. 5. Apply dimensional and positional constraints to the curve, ensuring the sketch is fully defined. Both sketches are now fully constrained and appear under the basic surface's geometrical set in the specification tree. Step 8. Reconstructing the top surface. With the sketches prepared and fully defined, the next step is to reconstruct the top surface using the sketches as references. This involves creating a swept surface that follows the geometry's design intent. 1. Locate and select the Sweep tool from the toolbar. 2. In the Sweep tool dialog box, set one of the sketches, e.g., the horizontal line sketch, as the profile. Set the other sketch, e.g., the vertical line sketch, as the guide curve. 3. Preview the swept surface in the workspace to ensure it aligns with the input geometry. 4. If needed, adjust the sweep parameters to refine the surface transitions and continuity. 5. Click OK to finalize the swept surface. The reconstructed surface is now added to the basic surface's geometrical set in the specification tree, ready for further operations, such as trimming or extending as required. Step 49. Checking the input and output. Now that the remastering process is completed, the next step is to compare the input and output geometries to ensure they match. This is done by visualizing both models and making sure that all the remastering operations have been executed correctly. 1. Rotate, pan, and zoom the input and output geometries in the workspace to examine their alignment and verify they match visually. 2. Ensure that all features such as surfaces, corners, holes, and edges are correctly remastered, and there are no discrepancies between the input and output models. 3. If any misalignment or issues are identified, adjust the corresponding features and verify the geometry again until both models match perfectly. The input and output geometries should now match, completing the remastering process.